Imagine you want to extract specific information from blobs of text documents. That information may be personal information like names, addresses, job titles, dates, places, you name it. We can extract that information using a technique, a natural language processing technique named entity recognition. So maybe you've interacted with a chatbot before. While you're chatting to the chatbot, you provide some information in paragraphs or sentences, and it will detect entities in there, like names, dates, things like information that's useful for the chatbot to then formulate a response on, but also to detect the intention of your message. So chatbots is one of the applications that uses named entity recognition. Then what I've been seeing a while back is the LinkedIn scraping tool that can extract job titles, names, and so on. Other applications, virtual assistants like chatbots or more advanced ones. Search engines to understand the intent or the query, the search queries that you put in, the text that you put in. Information extraction, question answering, social media monitoring. Then I'm not going to go too deep into this yet because this is advanced stuff. So we are going to train our own BERT-based model right now in this video, but it's going to be on top of the BERT transformer model architecture. We're using is this NER BERT architecture. I did find an interesting substack on this using ML.NET and TorchSharp to accomplish named entity recognition. So I did inspire this exercise on that. However, I wanted to apply it to my own literal pet project, which would be about web scraping animal adoptable dogs. And instead of having to web scrape every single element from the websites, which websites are prone to change every few years, this is an example of a website I would be scraping. This is already one of the better examples with some structure on there. But it would be nice to extract all of this information without having to hard code the exact structure of this web page. So I could just get the container, do .text content, and then use the text to extract the crucial information. I will put the produced code on my kisscode.com/members or on my Patreon and on my Patreon. So check that out to get the code in this notebook. Let's quickly go over Fyodor's work. Credits to him. He wrote a Substack on his Substack. He wrote a post about it, and he has a link to the code that he produced as well. Let's first take a look at the data, because we're going to be training on our own for our own use case. So we'll be slightly modifying this, but just to get an idea. So Fyodor's dataset, synthetic dataset, in which we have a CSV file with a sentence and a label. The sentence basically has just a sentence, but with a few names in there, and then a location, and that pattern you see in most of these sentences: company names, locations, and so on, entities. And then it's labeled, like first, and it's a simplified example. So in this example, every word is a token, so or a potential entity. Let's see, but we only want to tag the ones that we find interesting, not the stop words and the filler words and so on. There's techniques to filter all those out. We may touch on that later. I think we already kind of did that with spam and ham classification, but more on that later. text preprocessing methods. So Alice is a person, then the ant we're not interested in. 0, Bob is a person, then some other words, 000, and then USA as country. And then you'll see other ones with state, country, city, continent, organization, and so on. So about 100 samples. So feel free to follow this entire Substack. I did link it down below. I did it, of course, slightly differently for my use case. So here you see those entities. These are the labels that are interesting for this application. So this use case, the entities he wants to extract or detect. I have to try out his example. I did that, it works. With some exceptions that he explains in the blog and the post itself. I did have to follow it because I was getting some errors on my application, and that had to do with the text preprocessing. So if you want an easy example, just follow use his data and his blog post linked in this exercise. But I'll be doing animal details, which is a bit formatted a bit differently. It's name, then the name of the animal, sex, then the sex of the animal, age, and then I had to make this into one word, which is the age, well, in a long form, and then a breed. It could be a mixture or a Labrador or whatever. And then you see each time for the keyword, I put a 0, and then the actual name, I put the custom label, let's say. And that's about 1,700 records, lines. And that's just a simplified example. So the first thing we'll do is install all our packages, Microsoft ML.NET, data analysis, like we usually do. But this time we do have TorchSharp with a specific version. And then CUDA Windows to use my GPU on my Windows computer. I have a specific version for libtorch, which this package uses. Okay, then all our using statements, TorchSharp, data transforms, data analysis. Then we get to the model input, which of the first column is our sentence. And then the second column is our label. But I did it a little differently because this can be of variable length. Well, both the sentence, the amount of words in the sentence can be variable, and the label should be labeled correctly. So that means if I add more words in front of here, for example, like say this dog's name is Dobby, for example, then I would have to do something like, for every word that I'm not interested in, like this, and then dog could actually be like a species or something. Species could be interesting. I'm not sure what he's gonna do with the apostrophe S. But the name is not interesting, and the is also not interesting. I'm dividing everything by semicolon, which is different than the Substack example. The Substack example is like an array with comma separated, and then the entire CSV is comma separated as well. I didn't do it, I thought it was a bit extra. But this is kind of how you label the data. Of course, I didn't do everything by hand. I did have my data prep notebook, in which I'm scraping this information from the website that I, for example, showed you. This is for educational purposes. Please don't be overloading these websites. But I'm using AngleSharp to do the web scraping. I made a video about that before. I will drop this notebook also on kisco.com/members or on my Patreon, but I'm not going to include the scrape URLs. because for your application, you likely want different, want to scrape different data, or construct your data set in a completely different way. You don't need to do this by scraping, but scraping could be an ID. And this is very specific for specific websites. You basically extract information from the HTML markup of that website. And then I scrape the pages, then the list of results, and then for each I need to find the detail link. Then I need to scrape the content of each detail link to get the detail information for each dog. That's quite a bit of work. And then I usually, in my real application, I have a lot of code to parse the details, like to get every single detail specifically. But what I aim to reduce now is that code, so I can just target the larger structure and then just get all the text content. Let me see. So I have, when the website structure changes, I have less maintenance to upkeep. So then once we get there, currently I'm only scraping, let's see, only scraping this block. But instead of going over each one, I just say, oh, give me the text content for each of these entries, split it on this symbol, and then we're going to get a name. For example, the first would be name and the actual name, then breed and the breed, the age and the age, breed and the breed, that's the sex and the sex, and the ref ID, reference ID. And then I'm building this CSV setup, and then I'm writing it to a CSV file. What I did have to do is some sanitization on, for example, the name, because in this simple example, each word is a token, and then and then this needs to be labeled correctly. So let's say I do Dobby, and then between brackets is already adopted or something. What happened to me when I first tried it? Then you're going to get index out of range exceptions because the name, and then you have this, all these words as tokens. You can likely solve that by tokenization or creating embeddings or removing all noise from your datasets, like stop words and so on. I quickly did that by replacing everything between brackets and only taking the first thing that follows on name and sex and age and breed. Then the ref ID I removed for now, for this example, but that could be interesting for my use case as well. Okay, let's see. So I'm not really using this load column and this model input to load the data, because it might be a better idea to have something like load column and then an undefined length. So multiple columns together, which I couldn't do, probably with the text range or whatever. But I did that below. Let's see, model input would just be sentence label, model output is predictions or predicted label, or whatever you want to call it. Then this label key is simply for our custom labels, which I specify here. I'm only interested in name, sex, age, breed. Ref ID is in there and species, but I didn't include these in my custom data set. So if I want to have these, I need to provide examples of those in my data set. Then initializing the ML context and specifying my GPU device ID. We're going to be training on using my GPU. That's why I installed that Torch CUDA package. The TorchSharp extensions, just to see the Torch device. This is something you can do in Python to simply check if you're using your GPU or not, and so on. Then I commented out this code because this is to load the CSV data line by line, but we don't really need to do that. But what you see here, the label is basically, we start from index 1 and then all the other semicolon separated columns can be added as label. So then you could have let's say your sentences are, in this case it's not variable length, but in the case of Fyodor, his sentences are not of equal length, and so are his labels. So the idea would be that you can capture, so that just index 1, the column 1 is the sentence, and then anything that follows should be put together as the label. But we don't need to use this custom approach. We can just use, almost like we're used to, using the load text from file. Although I'm not using the model input because I didn't find a way to specify that variable length for the label array, but it's likely possible, not too hard to do. But I used this text loader approach instead, in which I can say range starting from 1 and then null as it's basically a dynamic range, which, well, the length can be inferred by this text loader. So then you get a vector string. It's detected the length of 2, but this could be, could have been a variable. Going to the data frame, and you can also see that in Fyodor's example, that could be a variable 1. Sometimes it contains 7, it has a length of 7 or 8 or less, and so on. For my simple example, it's just always 2, but it doesn't need to be a fixed length. So you can see 0 name, because the first keyword I didn't need, and then the actual name is the name, what I want to detect, recognize. Same for sex, age, breed. This one has a ref ID, which I did not include. Let's see. There shouldn't be a ref ID. In my simplified example. Okay. But for my application, I may want to have that, but then I need to include it in my data set that I train on. Otherwise, it's never going to be able to detect that. Then we're loading those custom labels, so the only labels that we're interested in. We don't need personal information or other things. Setting up the data pipeline and the trainer, we are using those custom labels as key data. Label to provide the bird named entity recognition trainer, and specify the output name as predictions. By default, it is predicted label, so feel free to use that. Then we're actually training the model. It took me 4 minutes and 40 seconds, possibly on the GPU. Let's verify that. That's where I was. Let's see, we're already using the GPU. Maybe the video recording crashes now. Let's see. The GPU usage does increase significantly from 40-ish% to 70% in the CPU as well. And then we didn't learn, well, I didn't talk about training neural networks, but it's basically, yeah, I can't load it right now, but there's a batch size, so the amount of training sample it keeps in memory to train on. And then there's epochs, which is basically a training run, so it's going to be training on each of those batches. But that takes up, well, that uses the GPU, the memory, and it's pretty expensive to do that. I'm not going to, let me pause the video for training, or let's just continue because I already trained it before. Then we create our prediction engine, the model input, model output. Just made a function for that to predict on simply, could be a sentence or a text paragraph. We're going to write console log the text, this, which is sentence or paragraph, and then the predictions it made, the named entities it recognized. So if we do this, which is, I put it in Dutch, also to check whether it could function multilingual with multiple languages. So this is Dutch, naam, which means name, then the actual name, then the leeftijd, which is age, and then I had to make this age one word because it's not going to, well, it's like specified like this in the sample data, well, in the training data. We would definitely need to find a better approach to recognize an actual age. Then sex, male, breed, Labrador, reference 1, 2, 3, but we didn't train to extract that. And then I added a dummy word because currently the named entity recognition has an issue, which without this dummy word it would skip the last recognition for some reason. It has a problem in offset. Do it like that, it's possible that it's going to drop the breed while it's, so I do something like this just to add a dummy word. And then the name it completely fluked on. There's no name in here. There is an age, but it's only been able to detect it because I specifically put underscores in there as well. Then we've got a 0. Then we've got sex, which is predicted pretty good. Breed. And then the actual breed, the Labrador. Let's see. It did train 3 minutes 40 seconds. Let's see, no, it didn't get the breed. And he added, yeah, the results just got worse. Let's see. So you could specify some parameters like batch size. Now it's 32 and the epochs is only 10. Let's see, so the default would be like this, epochs, amount of training runs, it's only 10. You may want to raise that to 50 or 100 or whatever, but it's going to take a lot longer to train. The higher this batch size is, the more training data it's going to store in memory, and this could really exhaust your resources. If you put it like 2024, for example, chances are, oops, this is max epochs. And then maybe put this at 500. Chances are maybe your computer freezes, depending on what specs you have. So let's just keep it lower. 50 epochs can likely take 5 times longer, so be prepared for that. But then the result should be better as well. Anyhow, this is a pretty simple sentence, just like almost like I provided in the training data. For my use case, this is likely, well, ideally it could perform on like a complete text and extract all of the info out of it. For my use case, I only would need to have the name once and the breed once and this and the sex and the age. What we should be doing is checking the model metrics, but yeah, maybe we'll see that in a later video. As you can see, yeah, I definitely need to train longer and likely have more training data, but to use a custom data set, you see this can get quite tedious to label all of these. If you're building a LinkedIn extractor, there's probably already trained models out there, or services even, or even data sets that you can use that are already labeled. So maybe that could be a good idea to use that. But if you have a very specific use case, then you may have to label it yourself, which you could use web scraping for, or you could do it differently. There's definitely a lot of techniques out there. So maybe we don't need to label like entire paragraphs of text, but just enough varied sentences and to improve the data quality. But definitely a very interesting concept, powerful, I would think. For example, you could find out how, well, specific characteristics of maybe a property that you're interested in, or a list of properties, summarize or extract the specific characteristics. For example, how large is the property in hectares, and then, for example, you could enrich your application with it instead of, let's say, having specific filters on age and breed and sex and other stuff. You could maybe just have a search, a text field where the user can query, like it's talking to a chatbot, but then query your database, get relevant results instead of having to specifically code all these filters in and all the possible filters. You could, yeah. And also for the web scraping, you could make things a whole lot more dynamic. Okay, you can find the code again on kisscode.com/members. Once you become a member, you can get access to all of the notebooks, or to go to Patreon and get access to all of the code produced.